we're referring to this angle over here for part A. No, I just started the recording. Okay, so we are looking for this red angle over here. How do I find this red angle? Yes. Okay. 360 minus 330. Okay, so Zachary suggests that we take 360 minus 330, we get 30 degrees over here. How does this help me? Angles opposite side? You mean this angle has a relationship with this angle, is it? What is the relationship for these two angles? What's the relationship? Okay, never mind. It's okay if you don't remember the name, but you tell me the relationship. Are they equal? Are they equal? You look.
They add up to 1.
You must at least be able to tell me they add up to 180, right? So this one we call interior angles. Is it interior angle? Yeah, interior angles. Okay, so we call this angle, let's call this theta. So theta, okay, before that we've got this 30 degrees over here. We need to give them names, right? If I don't want to call them theta and so on and so forth, how else do I describe this 30 degrees? XY, where XYZ? Can I call this, can I call it NAB for this 30 degrees? NAB cannot. Why cannot? Because N over here, then I got N again, right? Then here you got another N again, what? So how? You can draw in your diagram. You can call this theta. You can call this alpha if you like. Okay? You got a diagram, might as well draw on it. Otherwise, you have to have a hard time labeling. So theta is 360 minus 30 degrees. No, minus 330. 30 degrees. Angles at a point. All your reasons are still important. Yes, you do. So we get 30 degrees for theta. Then next, alpha equals to 180 degrees minus 30 degrees. Reason, interior angles, parallel lines. So please check your working, your presentation. Is it the same as mine? So we get 150 degrees. So now the unknown angle ABC must be 301 minus 150. And we get 151 degrees. Okay? Part A. Do you notice that every time I'm dealing with angles, especially when they're in degrees, I will write down all the degrees everywhere. As long as it's angles in degrees, I will make sure I write down the degree symbol. Because if I don't, it will be in radian, which is incorrect in this case. So I will not leave it to the last step, then I write down a degree. Everywhere is degree, I will write degree. Especially so for your sine, cosine, tangent. When you are dealing with, for example, sine 30 degrees, you write it down without the degree symbol, I will take it to be radian. Then you know that the answer is going to be different already. Sine 30 degrees is half. In radian form, sine 30 will be negative 0.988. They are different values. So I insist that you write down the degree symbol when it is in degrees. Yes? If you don't have the reason, then you cannot justify. Then I cannot accept. You mean you drew this, is it? Then? So 330 minus 270, you get 50 over here, right? Is it? Oh yeah, so you get 60 over here. And then? B draw down. Then what do you get? A, B, E, okay. And that will be? Okay. You're just going one big round to get this same 30 degrees. And then you're using alternate angles, right? Then, after your 30 degrees, you plus another? To get that part. Then after that, you take 180 minus that part to get that part. Then you plus it to 30, right? Can, but you sound like you go one big round. Then you have to draw them in, and you have to label them correctly. Then from this part, I hear that you have okay, this one only reason, but you should have one alternate angles parallel lines as one of your reasons. Okay? Yes, Cosby, do you have a question? Have. Next topic. No, it's not tested. At the moment. At this test? Yeah. Continue your question. Can put, but I'll penalize lah. Okay, next one. The distance AC. A to C. So here I have a triangle with two sides and one included angle. So if I draw it out for you, okay, I hear some of your reasonings are correct already, your approach. Is it cosine rule? So I draw the triangle, B, C, this is 14 over here, and A, this is 16. And this angle, we just found that how much is it? You forgot. 151. So I want to find AC. So according to our cosine rule, AC square equals to BC square plus BA square minus 2BC BA cosine 151 degrees. But I said you can actually do the substitution straight away already. So we get 14 square plus 16 square minus 2, 14, 16 cosine 151 degrees. So AC will just be the square root of that value, round it off to 3SF. And of course, put in the units in kilometers. How much is it? 29.0. Okay, thank you. Then the bearing of C from A. So far what we have done is a lot of basic only. Yes? Can you sine rule or not? You can find BAC. How you find BAC? BAC 330 minus 270. Then you get this part what? You don't get this. So cannot. When you use sine rule, do you get the correct answer? You mean you got the sine? Okay, then what do you get for this angle? What do you have for this angle over here? BAC. 13.5. Okay, then how do you get this 13.512 degrees? How? After this question, then you got your 13.512. That means you are not using the most efficient way already lah. Yeah, okay, so Racy, you did this question for part B using cosine rule, yes? For part A you use cosine rule. Yeah, part B you use cosine rule lah. So Shian is asking, can we use sine rule for part B? I'm sure you can, but there will be more steps involved. Okay? Okay, back to part C. The bearing of C from A. So this is our original diagram. Bearing of C from A. How do we indicate in the diagram the bearing of C from A? Draw a line, yes. We join up A and C first. Oops. You must have this, And then where are we measuring from? From A to C. So where do we put our compass? We put it at A. And we go clockwise until this part. This is the bearing of C from A. Well, now that I know the angle over here is 330. I want the red angle. I want this red angle. How do I get a red angle from this blue angle of 330? Cannot measure with compass. It's not to scale. Huh? So how do I get a red angle from the blue angle? Minus off which part? This part, right? Minus off this little bit here, right? How do I find this angle then? This is when I use sine rule. I have 13.512, right? How do you all get it? This is 13.512. Use your sine rule because earlier on you already got AC as 29.0 what? What is the 5SF value? 29.0? 4849, okay lah, quite similar. So let's just put 48. So this part is 29.048 kilometers. I want to find this unknown angle, BAC. So I use my sine rule because I have a side, I have the opposite angle. I have the side, I want to find the opposite angle over here. So now I put my sine on top. So sine BAC divided by 14 equals to sine 151 degrees over 29.048. Now, BAC will be actually sine inverse 14 sine 151 over 29.048. Okay? So get the answer, round off. What's the correct answer? 13.5. Huh? Or? Oh, wait. How come you got two answers?
180 minus the sine inverse.
Because the other value is actually?
180 minus sine inverse.
Yeah, actually that's something I always forget when I come to E-maths. But good thing you remember it, minus 13.5. So we reject this. Because very clearly this is an acute angle. Okay? So now, this is in degrees. BAC, we've got 13.5 degrees. So, we are now ready to find the bearing. Bearing of C from A is 330 degrees minus 13 point, what is the 5SF value again? 13.512. 0.512 degrees. So we get 316.488. Okay, so round off 316.5 degrees. Can? Remember, your bearing must have 3 digits before the decimal. So in this case, since it is a 300 over value, then it is definitely 3 digit already. And then the last one, distance AD. Yes? Must you write this, is it? Honestly, if you leave this out, we are okay with it. Because we assume that you are aware this can't be one of the answers. Okay? But actually, it's because you all forget to put it in. It's not because you all know you have to reject. But we close one eye. Okay, next one. Find AD. I see a right angle triangle. Sine rule. Where? How to use the sine rule? Yeah. I have the hypotenuse. Okay. AC we found it to be. How much was AC? 29.048. Okay, so this is 29.048. I've got a right angle triangle. So I need one angle. Cosine, is it? Which angle do we have? CAD, do we have that? Then you can use our cosine. Find C. Yeah, they want this. What's your point? Find angle C. You want to find this angle? Using what? But why do you want to use sine rule where you can simply use a trigo ratio of cosine? You see, we already have this angle. I have this side. So cosine CAD, which you all say you all have lah, equals to AD, which is my unknown, divided by 29.048. So from here I get the unknown AD already. Generally, okay, not generally. When you can use trigo ratio, go ahead and use trigo ratio. Don't always have to use your sine rule. Okay? Because sometimes sine rule will take more steps. You see trigo ratio, use it already. Okay, so that's for question 10. Did you all need help for 11? Yes. Who needs help for 11? Raise your hand. Okay. Question 11. Can. So now I want to find the side AC. There are 3 triangles in this diagram. If you are at a loss, which happens quite frequently for me sometimes, I try and list down everything that I know. Based on this diagram, right, what are some of the first few things that you can tell already? Angle ABC. Okay, how much is that? ABC, 180 minus 128 degrees. What is the reason? Adjacent angles on a straight line. Don't miss out all these words.
So if you don't write, can get penalized?
Can. Adjacent angles on a straight line. Check your work. Do you have the word adjacent? So we get 52 degrees. Okay, this is 52 degrees. Now for this triangle ABC, for triangle ABC, I see that I've got 2 angles and 1 side, which means I can use my sine rule. If you are at a loss of which rule that you can use, whether it's sine rule or cosine rule, you just do a quick check. Try and error. You only have 2 choices. This is not right angle triangle, so you cannot use your tuan So now, if I choose to, for example, if I want to try cosine rule, okay, I try using cosine rule. Then I want AC. Okay, AC square equals to AB square plus BC square minus 2 blah blah blah. I don't have BC so I cannot use it. Okay, I cannot use my cosine rule already. So now I have to consider my sine rule. Sine rule, okay, I want the AC side divided by sine 52 degrees, the opposite angle. And this must be equal to another side over a given angle. Which other side plus angle do I have? AB, okay, the side AB as well as the angle. What is the angle over there? Is it 64? The side is AB, which is 21 over here. So it will be 180 minus 64 minus 52. How much is that? Oh, still 64. Okay, so I now have AC equals to 21 sine 52 degrees divided by sine 64 degrees. Yes? Is it an isosceles triangle? Yes, based on this calculation, I get 64 degrees. So this is also 64. This must be the same as this. Why you always want to use cosine rule? Okay, yes, you can use cosine rule. Then before that, you prove to me this. You must get the side BC lah. So you need to write, because the 2 angles are the same, therefore this is an isosceles triangle. Therefore this side go to this side. Therefore I can use the cosine rule. Up to you. Okay? You will still be correct. So you get an answer. How much is the 5SF value? How much? 1, okay. So 5SF is enough, round it off to 18.4 kilometers. Now the distance of AD. Okay, hang on. Zachary says, find angle ACD. Yeah, we can find that. Since this is 64 degrees already, we know that ACD must be 116. Okay, you go and figure out how to present it yourself. I don't need to spoon feed you. So since this is 116, and I already have the side AC to be 18.411, then I want to find this side. I have 2 sides. I have 1 unknown side, and I have 1 angle. Which rule do we use now? Yeah, we use cosine rule. So for part B, we write AD square equals to 18.411 square plus 27 square minus 2. Copy down the same numbers, 411, 27, cosine 116 degrees. And find the value of AD. Please remember to square root it and get the answer. And finally, the bearing of D from A. Have you identified where is the bearing of D from A? Okay, D from A, English. Where are we measuring from? A. So the compass is at A. I must put my north arrow over here. Then I go clockwise to point D. So this is my unknown. Since I already have this angle given in the question at 64 degrees, I just need to find this part. We already have one side, one angle plus another side. Whether you use sine rule, cosine rule, doesn't matter. You will be able to get this value. They add them up, you get the bearing of D from A already. Okay? What is the answer for part C? 102.7 degrees. Okay? So I believe that's all for your homework questions. 102 ah. How do you get 102? Okay. What was our... Okay, you need to agree that we just need to find angle CAD. Then we just add it to our 64 degrees, we get a bearing already. So angle CAD for this triangle, I have 27 over here. AC we found earlier, how much was that? 116 point what? AC in part A, what do we have? 116.4. 18.4. What about the... do we have the side AD? Yeah, how much was that? 38.8 degrees. No, not degrees, 38.8. Then we want to find the bearing, this angle. I can use my cosine rule. 27 square equals to 18.4 square plus 38.8 square minus 2. 18.4, 38.8 cosine of the unknown angle, which is CAD. CAD. Make CAD the subject. Get an answer. Then we add this angle, so the bearing. Yeah, you can. Just show you that there are different possibilities. Okay, so this is the cosine rule method. So the bearing will be 64 plus CAD. This is if you want to use cosine rule. Then your friends are telling me that, hey, we can use sine rule also. Yes. Which angle do we have? ACD. This is 116 degrees. What other angles do we have? Okay. So now, if I want to use sine rule, remove all these things. Because there's so much information given to us, we have the luxury of choosing. This is 116 degrees. So since I want an angle, I put sine CAD as the numerator. Divided by the side, 27. Sine 116 degrees divided by 38.8. You will still get the same answer. Yeah, so the bearing equals to 64 plus CAD. Huh? Oh, this one. This is just an angle. You put a 0, I won't penalize you. So you get an answer.